Good afternoon and welcome to Packed with Performance, Metso Outotec's webinar series. My name is Marie Nyberg and I'm responsible for Crusherware's marketing. Before we start with the topic, what is your web profile telling you? I have a few words to share. Whether you are operating a fleet of crushers at your quarry or a contractor moving between projects and sites, by subscribing to this webinar series, you can expect to gain exclusive information from our top experts and leaders. Some topics provide better fit for a more technical audience, like today, some for business audience, and some for all. One thing is for sure, there will be something from everyone. We are having this webinar of different shapes and form. Majority of our webinars will be tackling various aggregate challenges and will be packed with practical and actionable tips. We will also have launch webinars revealing new products and services, as well as keynote webinars focusing on aggregates innovations, new technologies and strategic initiatives. This is for our webinar series demonstrates our commitment to build the strongest aggregates community in this industry, and sharing our know-how will help our partners and customers to become stronger and more resilient at all times. So before we start with the topic, I have some practical things to share. Can you please change picture of Washington? This webinar will be recorded and the recorder will be distributed after the webinar. Please use the question box. You can see how it looks. And type your question during the presentation and we will answer them after the presentation. And if you have posted questions that haven't been answering during the webinar, we will answer them via email. Can you please change slide? So this is just a safe harbor to tell about what we're sharing. And can you please change slide? So I'm proud to introduce our speaker, Washington Louis. He's our global business support manager for aggregate crusherwares, and he has an extended experience here in crushing and screening business. He's been spending more than 20 years with this. He have also been product support manager for crushing and screening products and have experience from management of technical assistance, technology transfer, and plant engineering. So he's really one of these guys that can tell us really much about this topic. His background is mechanical engineering business manager, and it's really good because he's fluent in English, Spanish, and Portuguese as well. So don't hesitate to speak or ask questions in any of these languages. So please, Washington, I leave the stage to you.
Hello, everybody. Good morning to some of you and a good afternoon to some of you as well. We are here today to talk about what the crusherwares are telling you. And this is an important point, as this is the material where the stones and the minerals are passing through the machines, and then it gives the performance and shape and quality of the final product. So before we start, let's talk about safety. We always in Metso Outotec, we start speaking about safety. This comes first always. So taking care is our common mission. We are committed to taking responsibility for our own safety and for the safety of others. Whenever visiting a customer site or in our facilities, this is what we have and what we do. COVID-19 has an impact in our markets. In this difficult situation, we are doing our best to support our customers. We believe that all accidents can be prevented, so zero injuries is our long-term target. We will cover here two kinds of crushers, as they are mainly found in aggregate producers. So cone crushers and the jaw crushers, they are very common to be found in many quarries or contractors' plants. Let's start by the cone crusher. So a little bit of introduction. Maybe many of you already know those words that we are saying here when we talk about bowl liner and mantle, the main components of wear parts on a cone crusher. Then we have the CSS that we call closed side setting, that is the adjustment of the machine, the minimum measurement when the rocks are passing through the crushers. They have to pass this aperture, and this is the minimum and where we calibrate the final product. Feed opening is the maximum opening where the material is going to enter in the crushing chamber. And nip angle is one of the most important also measurements we have in a cone crusher. This is usually calculated by our engineers, and it is very much important when we are dealing with stones that have a very low crushability. It means, for example, the river stones and also basalt or diabase, that are material that many times they jump in the chamber and keep there like boiling. So nip angle is the most important parameter to keep the performance of the crusher when we have this kind of material being crushed. When talking about the wear for the cone crusher, we have 4 main different kind of wear. The first one on the upper chamber abrasion on the left upper side, you can see that it happens on the top of the crushing chamber. Then we have the one that happens in the lower part of the crushing chamber. We have mismatched liners and also overworn liners. And the overworn liners is the most common that we can find in the crushing plants for many reasons. So high wear towards top of the chamber. Let's talk about each one of them. This is usually due to a feed is too large for the crushing chamber. So the material stays on the top and bouncing or boiling and wear out this region. So boiling feed at the top of the chamber and the difficult of slippery feed. Possible consequences: poor utilization, short lifetime, decreased capacity, and increased probability of catastrophic failure. Why decreased capacity? Because the material stays there and block odors from the top and from flowing through the chamber. And also they stay there like boiling, and then they do not go down. They stay there for some time, and this is why the capacity drops a lot. Many times 20%, and sometimes if we have a really difficult situation, if the nip angle is not good, the closed side setting is too tight, and the chamber is not correct, it can be that the production is going to drop 50%. So this is a really very much important thing to take care of. Solution: slowing down the speed. When we talk about HP crushers, that we have this possibility. Decrease feed top size, that is the most important one. So closing the previous crusher, if it is a secondary cone crusher or the primary jaw crusher, close it down the necessary so that we can calibrate the material that is going to be crushed by this specific stage. Then we can also check for a suitable cavity. If a coarser cavity, if we are using a standard fine, maybe we can use a standard medium, or we should use a standard coarse. We have to review the application and then adapt the chamber to that application. It happens many times that we sell a machine, and so in a certain point the customer decides to change the application, not to use it the place where they were planning to use. So then it's very necessary to review the application and the chamber profile, and sometimes also the speed of the crusher. This is an important point, and that's why we have our technicians visiting the customer and doing the startup. So at this point we can check it out and adapt the machine to what is needed. So available options to solve this problem can be create a step or do a proper selection of the chamber. Another option would be to add a retard bar. This is not very common to be done, but in some specific cases we can do. And other one is also adding a step. So we can, if in case we are starting up the machine and it's really necessary to do it very quickly, it's possible to machine the top area of this crushing chamber and then have a proper profile. Or if we have it in the stock of the distributor or in Metso distribution center, so it's easy to send to the end customer and do the replacement. So lower chamber abrasion, we can sometimes call it cupping as well, because it creates a depression at the lower part of the mantle where the material that is flowing from the top sometimes stop here, or many fines accumulate in this area. So we call it cupping. The cause of this, too many fines in the feed, not feeding enough material, crushing only on a certain level of the chamber, and single particle size feed. It means particle size that is going to be crushed just in that specific region, then the manganese is going to wear out in that and create this cupping. Possible consequences, packing. Packing means that the crusher can start to bounce. The adjustment ring start to move and bouncing, and so you can hear a lot of noise. This is one big problem. It means that the forces are too high. Increase the crushing pressure that goes to the cylinders and hydraulic cylinders, and also creating this bouncing on the adjustment ring. Decrease the capacity because the material does not flow well in the crushing chamber. It stays there longer, so you can decrease a lot the capacity, 20, 30%, or sometimes more than that. And ring bounce, as I said, and decrease liner life, as you have to take it out with a lot of manganese at the bottom of the mantle and on the bowl liner as well. So you lose a lot of manganese and wear life. Solution, adjust feed arrangement, and you can be on the screening process. It can be also having the proper feed coming from stockpiles or selected stockpiles, so you can select it according. Or maybe you have to change the liner profile to adapt to the situation you need, or adjust feed level. Many times also, if you keep the chamber level high, sometimes up to 500 millimeters on the top of the feed plate, then you have the perfect situation for the tertiary or quaternary application, where you have full chamber, and even more than that, the 500 millimeters above the feed plate will create a pressure to this material flowing better through the crushing chamber, and also improving the cubicity, the end product shape, and sometimes producing more adequate fines for your production. Then we have this other situation that can happen, that is a mismatched liners. It happens when we have different bowl liner profile when comparing to the mantle. For example, we have a standard medium bowl liner working with a short head mantle, for example. Then you have a different mismatch, and they do not work perfectly. You have the mantle with a wear profile just in certain region, because the bowl liner is pressuring the material there, and then you don't have a proper and full liner wearing in the full length. We can see here we need to have this overlap. We can see on the right side, on the bottom, a picture where we see the overlap of the bowl liner over the mantle. This is the situation that we need to have usually. So causes when two liners from different chamber, as I said, styles are used together, and possible consequences, choke zones and lips can develop. If overlap is too big or too small, a lip can develop, which will impede flow of material. Solution: make sure that liners are designed to be used together. And be careful also using other suppliers than Metso Outotec liners for the Metso Outotec machines, as they can, in some situations, do not have the proper design and proper dimensions to work as they should. And we have also situations that we see uneven wear. The wear can happen on only one side of the crushing chamber, as we can see here in the middle. This picture here, we see more wear on the left side than on the right side, because the distribution of the feed is not correct. So we have a segregation, or we have a lot of feed going only to one side. So causes poorly distributed feed, non-homogeneous casting. It can be as well if it's not well produced. And so possible consequences: ring bounce, because a lot of pressure in a certain region of the crushing chamber, and the poor particle shape, uneven liner wear, and imbalance of crushing forces. Why poor particle shape? Because you have if you have segregation or distribution is not well, what happens is that you have too much porous material in one side, so you don't have the fines between them that create this crushing between stone. So it will be creating slabby material, and also you won't have a very good shape at the end of the day. Overworn liners. That, as I said, this is the most common situation that we can find in the customer side. So failure to monitor liner wear. It means they forgot to monitor it, and or it's monitoring one day and one day not. So it can be that it's worn out and it should be already replaced, but it's still operating. And stretching liner life. It means sometimes that the customer needs to keep producing to attend a certain contract with their end customer, and then they keep producing. And at the end, you have this situation, and so there are many consequences, like liners could come loose and damage machine. Seating surfaces can be damaged also or worn out on the mantle or bowl line or bowl itself, the two frames of the crusher. And liners crack and break apart. So it can happen also when they break apart, that they go into the crushing chamber like a uncrushable material, like a tramp material, and you can burn bushings or break bearings or break even a part of the work frame. So be careful about this and calculate well the damage that you are going to do, and if it's really let's say if pay the bill that you are producing more material for your contract. Solution: monitor liner life or collect data to forecast estimated life. And we can see on the picture on the right side on the bottom, there is this A dimension. It means if the operators know well how to do this monitoring, they know exactly the moment that they have to stop the machine for parts replacement. So what does good performance look like? Look like this. You see the drawing here of the liners. They have a straight line from the top to the bottom. It means the wear was very, very straight, and it means that you will have the best out of your crusher wears, and you will have the best rate of manganese utilization. That is usually 50%. So correct chamber for feed size. It means that you have chosen the correct chamber for the feed size of material. Good feed grading. It means that they are going all around the chamber, and you have material that is mixed inside, not only coarse or not only fine material, but a mixed material that is being crushed all together. And the consistent power draw numbers, that means that you have a power draw knot with a big variation. So for example, if you have 500, it means that it's keeping between 490 and 510 all the time, and you don't have a difficult, let's say, a big variation. And correct metallurgy also helps to make this. It means the manganese is good outside and inside, not only on the surface. It's good on all the thickness, and so heat treatment was done well. The manganese recipe is good, so the alloy and components is perfect. So you can get this very nice wear profile. So it always has a financial impact. If you don't have the proper selection and you have the proper wear liners, and so you can have a financial impact, and it's easy to calculate. I believe that it's so you have two mainly components to calculate. One is the number of changeout, and the second is how much capacity you lose when you don't use the proper wear liner. So you have to collect the key operational parameters. It can be for this specific case here, this example that we have, you have standard fine liners that was later on replaced by standard medium. The setting is 60 millimeters, it was kept the same, and lifetime was 150 hours, it was raised to 270 hours. Just with this change or replacement to install the proper chamber profile. So results, it was, when we do this, we could get 12 less changeouts per year. It means less cost because you have less labor, you have less risk of accident because people has to be around the machine, has to lift parts, have to tight, have to use many kind of different tools and do some preparations. So there is a risk. There are many machines and tooling involved, and lifting tools and so on. So there is a cost, a direct savings. You can calculate it easily here. And also, if you have 15% more capacity, it means an annual income increase. It's an extra production that you can have and sell in the market. We can easily calculate it by the capacity of the machine and how many hours you operate per year. So 15% more capacity multiplied by all of those numbers, and considering that the price per ton is $10 US, so it's more than $1 million per year of additional income. So this is really easy to show to the customers, and they understand easily that there is a benefit of choosing the right profile or doing some refinement of the improvement if there is any need. Now let's talk about the jaw crushers that are also very much important part of this crushing process. So the jaw crushers, they prepare the material for the secondary application for the cone crushers. So you need to take a very good care of it, and also to choose the right profiles in a way that it's going to not only give the right calibration for the material going ahead, but also give the proper shape for the material and improving, avoiding slabs, and so helping the cone crusher to produce and giving the proper quality of the end product. Some basic concepts to the jaw crushers as well. Feed opening, so it's the depth of the cavity, and usually the maximum feed size is approximately 80% of the feed opening. And CSS, again, that is the closed side setting, it's the adjustment of the crusher, and many customers, they prefer to use the OSS, that is the open side setting. So when they use this, they have to use a special table that we have in our instruction manual to convert it into the CSS. That is the number that we use in our production graphics and table as well on the product catalog. So nip angle also we have to consider. This is very important for the jaw crushers as well. If you don't have the proper nip angle, we will have again here the material bouncing on the crusher, on chamber, and so capacity drops a lot. And for certain applications like diabase or also basalt or river stones where the crushability is very low, the material is slippery, so we need to do some changes on the nip angle. And it can be done easily installing a spacer plate behind the fixed jaw. And we have it designed and from the factory so that you don't try to use any kind of thickness that could compromise the machine structure or bring any damage to the crusher. So we have it, and it's easy to get it from our stock. And again, it helps a lot, and it can, if you don't have the proper nip angle, you can lose capacity up to 50% and sometimes more. So take care of this and ask your Metso contact to talk with the specialist if you feel that it should be something that should be reviewed in your crusher. To get optimum capacity and maximum lifetime of wear parts, so check the feed size. Again, what is coming from the pit, from the quarry pit? Sometimes the blasting process, you have a very open, let's say the screen of the blasting process is too open or too wide, so the size of material is too big, and you have to stop a lot to take those boulders outside of the crusher, or you have to, and then you have to take them back to the quarry to blast them, or you have to calibrate it with the excavator. That takes a lot of time as well. So be careful with the blasting process so that you can maximize the capacity and avoid this problem when it comes to the primary blend. Check the feed arrangement. So the feed must be distributed evenly as well across the chamber, and the crusher cavity should be full. When we say full, it means it's not over full, it's not above the feed level, the chamber level, but at least at the chamber level, above 70% up to 100% of the feed level. This helps a lot on the capacity because the material is pressing the lower material down so that the capacity is going to be higher and make a easier grip of the stones by the jaw dies. So this is important. Apply proper scalping. It means take out the fines from the primary. Do not let them go into the jaw crusher. If you do this, it means that they would be wearing out the jaw dies as well without any necessity because they are already in the proper size. And also you have earth, or you can be creating let's say you can be creating a lot of packing at the bottom of the crusher. And it's bad for the bearings and for the toggle plate as well, and for all the process, all the production. Check the wear profile of the jaws. Yes, an uneven wear profile will decrease capacity, increase wear, and increase crushing forces. So this is a point that it's always important that your Metso Autotech contact go with you and evaluate what is going on. And sometimes if they take a simple picture of the wear profile and send it to a specialist, they can easily see if there is a need for a replacement or if there is a need to do some more deeper analysis, taking more information from the site and operational information, maintenance information, and applications so that we can really develop a better solution. But the picture of it can already help a lot. So how a normal wear looks like. This is how it looks like. It's from the top down, you see it's very even. So it's not a deep or there is any valley on the jaw dies. So normal and smooth, it means suitable feed for the cavity, good and continuous capacities throughout the lifetime of liners, and optimal lifetime and scrap rate. So those are the characteristics when you have a very good wear profile. So like the cone crushers, we have wear from the top, wear from the bottom, wear on the middle. So this is very much similar. One thing that we really have to avoid is over-worn profile, because on the jaw crusher, when it happens, so you don't have resin to help protecting the structure of the crushers. So the stones are going to be crushed direct on the structure. It means on the pitman or the mainframe front part of it. So avoid the overwear. When it is worn from the top, it means it was rotated too late. You started the operation, but you did not rotate the jaw die at the proper time. It means that it came very thin at one corner, at one end, and then so it will be difficult to have a proper operation. Large nip angle, rocks are bouncing, reduced capacity. Nip angle, it means that the rocks are bouncing on the top or somewhere. So on the top, they would stay there, wearing out the material, and then it will happen this, what we see right here. Wear profile from the middle. So it means that you have, if you have one piece jaw, it means that it would be there and you will lose a lot of manganese because you have to scrap it very soon, and then you have the manganese on the ends, and that was not utilized. So possible reasons: material is dropping to this point from feeder. Check the dropping height and the velocity of feed material. You can have also one size of feed. It means a very specific gradation of the material coming from the quarry, or because it was selected some time ago in the quarry pit and now they are sending all of them to the primary crushing plant. Then you have this specific point being worn out. And also could be cavity design. You're not using the proper crushing chamber to that application. Possibility to pour lifetime and capacity if cupping from the middle. Yeah, sure. So you'll have some material stopping at this part when the cupping is very deep. You have this worn out very deep. So the flow of material will not be adequate, and then the speed is going to be much lower stopping at the middle, and then you decrease the capacity. So usually you can lose 10–20% of the capacity very easily when it happens this way. So wear from the bottom. This is another profile, and you can easily see it when you go to visit the scrapyard of the customer site. And sometimes you can even go deep on the bolts, and but you see here how it is, and if it goes deep also on the seating surface that is behind the jaw die, so you start even to wear out the pitman or the front mainframe. And this is bad. You can have the jaw plate not loose, but you can have it moving, and then you have a problem on the surfaces of the structures as well. So possible reasons: small setting, fine fit gradation, cavity design. Many times, if you're not using the proper liner on the jaw crushers or on the secondary crusher, you try to compensate this using a very small setting on the jaw crusher. And so the consequence is what we can see here. So selecting the proper liners for the secondary also helps the primary jaw crusher. Sometimes the customer is using this very small setting also to produce the final product from the primary crusher. Then it happens this way. Sometimes, okay, if you calculate and it compensates, it's financially it's good for you that you are producing only with one crusher that specific product for your customer, so that's okay. But it's not okay for the machine. Take care and do not take very long to replace it for a new one. Possibilities to poor lifetime and scrap rate. This is the consequence of doing this. And if setting is too small, increase the power draw and crushing forces. that can go direct on the pitman structure and also on the roller bearings. So take it in account also that you can decrease the lifetime of your roller bearings when you do this with the machine. Cupping is another characteristic that can happen with the jaw dies. So possible reasons: small setting, fines in the feed. You see that the difference from the lower part of the jaw dies wear is that it happens almost at the end of the jaw die, but it creates a deep depression, and there is where the flow starts to stop and you lose a lot of capacity. So small settings can do this: fines in the feed, fine feed gradation, cavity design. And possibility for low capacity, high power draw, and increased crushing forces. Again, it's almost the same as when you are having a high wear on the bottom of the jaw dies. And as I said, again, here we can see clearly on the picture below, down on the corner of the right side, that when you visit the customer scrap yard, and some customer call it a bone yard, when you visit there, it has a whole story about the crusher. So you can see how it was behaving and how it was being treated and what was the customer need. Of course, they do this for a reason, and but so you can discuss and try to find a solution that can be on the secondary crusher or on the primary crusher itself, changing the jaw dies, or maybe on the quarry pit, and try to find a solution out together. Discuss and take time on the boneyard, on the scrap yard, to discuss and find the proper solution for the customer side. You will be improving the plant capacity and improving the shape of the end product. So it means quality of the material that they are going to sell, and so they can capitalize on this as well. Yeah, this one is very much specific and many times is related to the maintenance process or quality of the jaw die itself. So maintenance process, I mean, because when the customer or when someone is replacing the jaw dies, what happens is that they do not tight well the bolts, or there are some dust or material between the jaw die and the structure or the pitman, and then you have some gaps behind it. You tight the bolts, it starts to operate, and then suddenly you have the parts are bended. So, and it can be also because of you did not, so the bolts were not retighted. You know that frequently you have to retight the bolts to keep it, because the manganese parts, they can have some deformation along the period they start to operate. So after some hours, you have to go and retight the bolts, and along the process also they are wearing out, but they can have some more deformations and reduce the thickness somewhere because of the pressure, and then it's important to retight the bolts. Check, it's easy to check if they are tighted. So you look at the instruction manual, you see that there is a certain thickness of the washers, and that has to be there in place, and then just go there, retight, and you keep it safe. So reading here the presentation, we have possible reasons. Released casting stress during the crushing process. I would say that it's a kind of quality of the manganese parts. It should not happen at the customer site. It should happen at the oven during the heat treatment. And we do not see this. There are many years that I do not see this happening with the Metso Outotec parts. Then design of the jaws, if they are not well designed and the dimensions are not proper, if the angles are not proper, so it can happen. And dirty seating surface during installation, as I said, poorly fastened jaw, installation of wedges, tightening, etc. Jaw bolts not tightened regularly. And possible outcomes: damaged fastening wedges and lower wedges, damaged pitman or front frame. This is so sometimes you can hear the if you do not tighten the jaw bolts well, you can hear some hammer noising, and this is something that you can hear from far away from the crusher, and the customers usually they know that is happening. They go there and tighten the bolts, but do not wait this noise happens. Go there and tighten it frequently as the instruction manual says to do. Things to find out: when you rotate the jaw die, sometimes if you rotate it too late, it can create a depression at the middle of the crushing chamber if you use the two-piece jaw dies, and this will create a slower flow, because the material will stop in that region and the flow is not going to flow well as it should be. The speed is going to be lower, and you can have a capacity decrease. So this is all I had to say today. I hope it will add some value on your day-to-day life and your plant capacity, and the way you deal with your customers as well, and you have some more information to discuss with them and create value to them, and also opportunity to do more business. Thank you very much.
Thank you, Washington. So please don't be shy, enter in your questions. We have some questions already here, and Washington, is it common to find overworn liners in crushing operations?
Yes, it is, and it is common to find it for the cone crushers and for the jaw dies as well. As I said, it is very dangerous for the crushers because you can damage the structure of the crushers. And in the cone crusher, mainly if it fall down, a piece of manganese is cut and fall down inside of the crushing chamber, you can burn the bushings and you can do a lot of breakage and have a catastrophic breakage on the crusher. So, and it happens due to many situations. One is that okay, it's a new operator, he doesn't know how to do the measurement to see when it's the proper time to do the replacement, or because they want to stretch the wear life, want to have some more hours of wear life to take advantage of that manganese quartz, or sometimes they do not have material in stock, I mean, do not have the parts for replacement, then they have to keep the operation the way it is, because if they have a contract to follow and deliver the end product, and they do not have any other option, then sometimes it happens, the customer do this way. But of course, it's not the right way to do. It's not a good way to treat your crusher.
Okay. This retard bar, how do you fasten that to your liner?
Yeah, the retard bar is something that we use not frequently. It's very rare to need to use the retard bar, but when it's necessary, it's good that it comes from the foundry. It means it is in the casting, it's not installed on the site. If you really need to install it in the site to do it, like for example, oh, let's do a test here and see if a retard bar is going to help, and then we ask the supplier or to install it, to have it incorporated in the parts later on. So you can do this. You take a piece of steel, a ring, and then you should do the welding. It has to be with a stainless welding because it's manganese against the steel. So even so, it can break easily and go into the crusher. So talk with the Metso specialist or your Metso Autotech contact so that they can help you and give you the proper instruction to do this properly.
Okay, thank you. Why this with the catastrophe failure? How could that occur in the case of a too large feed?
Yes, it can happen sometimes if you don't have on the jaw crusher, you don't have a proper hopper that protects the upper part of the pitman. So the right place to start crushing the rocks is from the level of the jaw dies. not on the upper part where we have the pitman protection or on the pitman itself. So if you start throwing big rocks and they start hitting that upper part of the pitman, you can have problems on the bearings, or you can have problems on the pitman itself in the structure. And sometimes if you have a height and the material fall from a very high position and goes and hit the pitman, it can be that the toggle plate is going to get loose because the pitman on the bottom part go to the front as a cause of the heat on the top of it, and then you lose the toggle plate. And so you can have a catastrophic situation. Yes.
Okay, thank you. The max size of material for your crusher, do you measure the long side of material or the middle of the material? How do we measure it?
Yeah, usually when you measure a rock, you take 3 dimensions. It's the length, the width, and the height. So the height. So you take these 3 dimensions, and the average dimension is what we call it the maximum size. Because when you have the jaw crusher, you are feeding the jaw crusher, the operator usually can direct the rock inside of the crusher. They have this equipment that can be a hydraulic hammer or another kind of equipment that can direct the material and put it there in a proper way. So, of course, the easiest way would be to have the maximum dimension of the rock at that maximum fit size. But if you have the average dimension, that would be the best situation that for you to have the best production out of your crusher.
Okay, thank you. If the equipment is connected with digital systems and automation, is it possible to avoid severe anomalies? Sorry.
Yes, it is possible. Whenever you have the digital system, it will give you a lot of parameters that you can analyze later on, or you can analyze online as well. So it will show you high peaks of amperage or power draw. It can show you if you have it installed on the belt conveyor, also belt scale, you can see the variation of capacity. So, and you can see the variation of temperature of oil when in case of the cone crusher, for example. So you take all of those parameters and you analyze along the time. You can take a week or can take a day of work and see how was the performance and see how you can improve it.
Okay, thank you very much. Yeah, I think we covered all the questions, and can you please change slide, Washington? So thank you all for joining, and as I said in the beginning, we will share the recording with you after the webinar. If you still have questions, please reach out to Washington and we will get back to you. And please also follow us in social media so you stay tuned and up to date with everything that's happened at Metso Outotec, and also check out the upcoming webinars. Thank you all for joining. Have a great day. Bye.
Thank you all for the participation. Bye-bye.